Hey, welcome to another episode of AWS Cloud Bytes. I'm your host, Bhavesh Kumar. I'm a certified AWS Solutions Architect professional and a DevOps engineer professional. If you are new to the channel, please subscribe and click the notification bell icon. As usual, the agenda is to check out AWS news and solve some questions. Today's focus will be on understanding questions suitable for AWS Cloud practitioner. Let's talk about some updates in the AWS world. Okay, so let's look at this new news. Amazon DocumentDB now supports event subscriptions. So if you're familiar with DocumentDB or if you're familiar with MongoDB, MongoDB is a document database, and the DocumentDB is basically a managed instance of Amazon that is compatible with MongoDB. So if you look, what event subscription is bringing to the picture is that based on any event that is happening in DocumentDB, any kind of management event, it can be related to database changes or any updates that you want to listen to. So basically a pub sub implementation over here. So you can subscribe to those events, and based on your subscription, if such event happens, a notification will be given to you. So if you look at the kind of what's a notification is, what kind of events can be thrown. This is an example of SNS. So you can subscribe. Over here, there is an SQS that is subscribing. There is another SQS. There are three different instances of SQS subscribing to three different types of events. And the publisher of event over here is SNS. So if you look at this is going to be pretty good from a scenario where you want to change some events based on something happening in the data store. In this case, if there is a change in DocumentDB record, you can wire up some kind of automation around that thing by subscribing to that event and triggering other services based on the event. So pretty good change by AWS. Moving on, AWS Config adds pagination support for advanced queries that contains aggregated functions. Now, this is another news that is coming from AWS, and if you don't know what AWS Config service is, so you can go to AWS Config and read about what AWS Config is. So AWS Config is a service that enables you to assess, audit, and evaluate the configuration of your AWS resources. In brief, what we can say is in AWS config, you define what is your configuration or standard configuration, and it keeps an eye on your current configuration that is running in the environment. In any kind of changes to that config, that's one of the feature. Any of the changes of that config can automatically evaluated, recorded, and you can get all the notifications over here using SNS Topic, CloudWatch, or S3 bucket. There are certain use cases over here with AWS config, like discovery is one of the use case. Second is um, compliance as a code. Basically, you can build compliance using some standards that you can define in AWS config, and that can be reused multiple times. Change management, so you can keep an eye on how the changes are happening over a period of time and who did it. So you have audit and compliance. Um, it's a pretty good service, and the paging support that has been added to this is allowing. If you look at the previous limitation, there was a limitation of 500 rows that were returned from your aggregated queries. Now, using this pagination, you can return pages, which will be a subset of those results, those aggregated results. And this aggregated result is all about what kind of resources are there. The AWS Config Advanced Query feature lets you query the current configuration state of your AWS resources based on configuration properties for a single account and basically multiple account or single account in AWS region or regions where it is supported. You can either select one of the sample queries or add on your custom queries. So it's going to be very helpful for DevOps engineers or admins to look at the resources, query resources from one account, multiple accounts, aggregate them, and look at the results in a paged manner rather than just 500 records in one go, which was difficult if they were having more than 500 records because there was a max limit of 500 records. Moving on, announcing AWS Step Functions integration with Amazon EMR on EKS. So if you don't know about AWS Step Functions in brief can be just defined as a orchestrator. What exactly is an orchestrator? Basically, if you look at this picture, it's kind of a workflow. You define a workflow, and orchestrator will, based on rules defined in the workflow, orchestrator is going to execute one thing or other thing. So it's kind of a flow chart or workflow. This one is a serverless workflow. So if you look at this, an example of how step functions is working, this is a step function workflow here. Checking the inventory and holding products, kind of an order workflow, billing the customer, shipping the product. If the bill is failed, you were holding the inventory over here, remove the hold. If the bill is the payment is made, then uh, you go for it in shipping. So that's kind of a simple workflow. And what they're doing is, till now, AWS Step Functions were not supporting EMR clusters. So if you look at this, the EMR, Amazon EMR and EKS is a Kubernetes service, Elastic Kubernetes service of Amazon, and then the EMR is basically MapReduce. So it wasn't supported. With this change, now step function can actually invoke or execute things. There will be integration. So it can execute things, pass it to EMR cluster, and can make a workflow using those services. The three APIs that it is supporting is create virtual cluster. So it creates and register AWS EMR on EKS. Then there is a delete virtual cluster. So it's a synchronous, looks like it is a synchronous, deletes AWS EMR on EKS virtual cluster and then waits until it is deleted. So it's a synchronous path. If you put this in AWS step functions, it will have to wait until this particular deletion happens. Similarly, there is a start job run. It is again a synchronous invocation. It will have to wait until the job starts in EKS. In this section, we are going to solve some AWS questions. Let's try to understand the context and find some right answers. Which of the following AWS service will help in dealing with a single point of failure? You should aim to build as much automation as possible in both detecting and reacting to the failures. So looking at this question, we have to select um, two items out of these. And the thing we have to keep in mind is that there shouldn't be a single point of failure. Um, Anything that can reduce single point of failure. So we can go through each of these items. I'll give you 30 seconds to pause the video and take a look at the answers or find the answers for yourself. Single point of failure is something that you want to avoid. You should build as much as they say automation and detecting and reacting failures. So Amazon Athena, what do you think? Amazon Athena. Amazon Athena is basically a service that can use S3 as a source and do query. So does that help in single point of failure? I don't think so. So Amazon Athena is, we can discard this, so it's not a correct answer. You go to auto scaling. What exactly auto scaling is? Auto scaling is based on how the demand goes up and down, up and down. You add new compute instances or you reduce compute instances as per your need, basically. So auto scaling looks like a relevant answer over here. So I'm just keeping it as one of the options. What is Amazon EC2? EC2 is just a compute instance. So if you say it's just a compute instance, now if the compute instance is gone, it's gone. It's going to be a single point of failure, so we can discard it. ECR. So what exactly ECR is? It's an Elastic Container Registry, and this is just a kind of a repository for all the images that you have, Docker images that you store on AWS. So this has nothing to do with our single point of failure or as an option. Now ELB, how ELB can help removing single point of failure. Now ELB is Elastic Load Balancer, and there are three flavors of Elastic Load Balancer in AWS. One is Classic Load Balancer, which is a legacy one. It is not recommended by AWS anymore. There is ALB, which is Application Load Balancer, and then there is NLB, basically Network Load Balancer. So yeah, what ELB is doing is ELB is hiding your compute instances, any kind of compute that you have, behind one single point that it provides to the customer. So customer doesn't know who is serving the request. And if one machine goes down, ELB can add another one. It can add another one to maintain the number of compute. So basically this is all abstracted from a client or a consumer point of view. Consumer doesn't see that ELB is down. ELB knows that the compute is gone. So ELB is one of the options. So looking at these options, the two options that we can think of is auto scaling, because auto scaling can add or remove instances as per the need of, as per dynamic expansion or reduction of compute needs based on the incoming traffic or incoming request. And then the ELB will be helpful in basically distributing the traffic. So these are the two options for you. Question: which of the following must an IAM user, note that this is an IAM user, not a role, IAM user provide to interact with AWS services using the AWS command line interface? Which means we're talking about interacting with an AWS service using a CLI. So we have these options. You can pause the video and try to find an accurate answer for this particular question. So let's look at some of the options. We can go from at random, we can pick any. Let's talk about secret access key. Now, secret access key is a part of access keys. It's basically one of the items that is available as part of access key. So access key contains two things. One is access key ID, and then the second one is secret access key. Individually, secret access key doesn't make any sense. We cannot use it. When you generate an access key for an IAM user to programmatically access AWS services, you need a access key ID and a secret access key. So this is just a partial thing over here and is not reusable. The second option over here, option C, let's look at it, the username and password. Now, username and password is something that you use to log in to AWS console. You cannot use username and password to programmatically connect to any service. So basically this service, this particular option is not valid for this question. User ID. What exactly a user ID is? Basically, user ID is an alphanumeric identifier. It's a big identifier, which is a obfuscated form of AWS account ID. We don't use it as such. It is not used to do any kind of access, programmatic access. So this option is again invalid. The only option that looks valid over here is A, which is access key. Now, access key contains two things. One is access key ID. The second one is secret access key. So, as a user, this is an IAM user. Um, when you create an IAM user in the console, you can say add an access key, or you can say create an access key which contains these two things, 1 and 2, mentioned here. And then you can have multiple access keys. Now, these access keys are long-term credentials. Until they are made invalid, they are good enough depending upon what kind of policy they hold. Um, they can interact with one or more services depending upon the policy document attached with these access, whatever the access has been provided to this particular user. Now, user has suppose access to S3 only. So using S3 read write, then using this access key, they can programmatically, any application that has this user configured using this access key, which is access key ID and secret access key, can programmatically read write the AWS service S3 depending upon these policies. Now, you can have one or more access keys, but it is always good to have access keys rotated. Good thing is you can have like 90 days policy or 90 days rotation. You can programmatically write some kind of rotation logic around this to remove these access key and distribute the new access key. Remember, once you create an access key, you get these two things. You cannot fetch secret access key. This is only provided once you create an access key. So you have to store this somewhere, or you need to download this. Else you cannot use. You have to use them in a pair. You cannot use them. You cannot fetch this later. So if you lose the secret access key, you have to disable. You should disable it, the previous one, and create a new access key. Don't delete the previous access key just to keep it track. You can delete it later once you don't have any kind of issue because of disabling of this access key or secret key when you are doing rotation. So the answer to this particular question is access keys. Which of the following helps a customer delve deep into the EC2, Amazon EC2 billing activity for the past month? Now, this question is about the billing activity. You have to look into the details of bill that is generated, the monthly bill. So these are the options that have been given. AWS Systems Manager. Well, if you look at AWS Systems Manager, it is a unified user interface that provides you information about the operational data from multiple services, basically. It doesn't give you any billing there, so there is no billing in AWS Systems Manager. TCO, so AWS TCO service is basically total cost of ownership. It's a calculator. It tells you if you run the same service in your on-prem and if you run this in cloud or cloud, so basically this or this, which one will have better ROI? So basically, which one will be expensive? So how much cost will you have to pay running the same service on-prem versus in cloud? So that's a TCO. So this doesn't give you option, this doesn't give you billing info. AWS cost and usage report and AWS budgets. So if you know AWS budgets is something you might be doing on a monthly basis that you are budgeting. So basically you create a budget and create budget and then you track it, right? So budget is similar to, as the name suggests, it is very similar. You create a budget and then if the budget goes beyond, if there is a forecast that goes beyond your budget, so suppose you budgeted for $100 and then the forecast is telling something like that it is going to go beyond $100, it can give you a notification, or if you track on the actuals, it can give you another notification saying the budget is that you have gone past your budget. So this is not to give you details about your cost, but it is to tell you that you have created a budget and how you're tracking around that budget. So that service is not an answer for this particular option. Now looking at AWS cost and usage report, yes, AWS cost and usage report gives you details about each services. You can group by services, regions, availability zones, resource types. And there are many groups that you can do. You can drill down and look at daily, monthly, hourly. A lot more detailed information can be looked into this particular thing. So this is the right answer for this particular question. Okay, moving on. A company is wasting a lot of money on underutilized, so remember, underutilized computer resources. What does it mean? We're not using our computer resources in the AWS. Which AWS feature they can use to ensure that their applications are automatically adding, removing compute capacity to closely match the required demand. So this is a true case of cloud. When you say I'm in cloud, I should be looking at pay as you go um, based on my consumption. So suppose this is a graph where this is my consumption, and if I consistently pay something like this, then I'm actually having this much compute capacity, which is higher than my actual requirement. How the compute should track is that it should be somewhere a little bit higher than your actual required compute. So that is, they are trying to remove this gap. Um, Now looking at the options over here, you can pause the video and you can still go ahead and try to find an answer for this question. AWS budgets, as you know, AWS budgets give you an ability to set up custom budgets and get you alerted when your cost or usage exceeds forecasted or is forecasted to exceed your budgeted amount, or the actuals are around your budgeted amount, depending upon how you are tracking it, whether you're tracking by forecasted. You're saying get me a notification when it is forecasted to be passing my budget, or when the actuals are passing my budget. So that's an option over here, which is not true because it is not going to reduce your um, add or remove your compute capacity. Now, the second one is AWS auto scaling. What does auto scaling brings to the table? Auto scaling is something that adds or removes compute based on your usage. So if you look at this graph over here, it adds compute basically if this is your actual consumption, and this is what you're adding based on your actual. So this is something that it is looking at. This is actually an correct option as of now. Let's look at other options. AWS Cost Explorer. Now, Cost Explorer is something that gives you breakups of different cost groups. So you can look at cost on service, you can look at by resource, You can have by region and all other good things. So many groups, and you can have very details in days or months, something like that. So it's basically a reporting tool that allows you to drill down to your cost that has already occurred, um, and there will be some kind of forecast also if you are looking at the forecast. Now, elastic load balancer, this option doesn't give you that flexibility to add or remove compute as you need it. Elastic load balancer. Now the load balancer is going to balance the load. If you have a load balance over here, um, load balance here, and they have compute nodes in, they all are sitting in target group 1, TG1, suppose, and there is no scaling in TG1. So the number of compute that are going to run this in this TG1 will remain consistent, or target 1 will remain consistent. If one of them dies, it will reduce. It is not going to add a new instance until there is a scaling policy added to this target group. So this in itself is not going to solve the problem, but the underlying, so this itself is not the solution. The auto scaling, which can allow the target group to add or remove the instances, whether it is consumed by elastic load balancer or um, any other aggregator or any other service on top of it. Um, this is the underlying service that helps you do that. So the answer for this particular service is auto scaling. The question is auto scaling. An organization must reserve EC2 compute capacity for 3 years. We're talking about 3 years compute capacity in order to get more discounts. Their application workloads are likely to change. So the workloads are going to change during this time period. Which EC2 reserve instance type will allow them to modify the reservation when required? So which EC2 reserve instance type, so there are multiple types of reserve instances over here, will allow them to modify the reservation when required? So if you look at the options, as usual, you can pause the video and search for an answer. If you look at the options over here, we can start from the bottom here. Standard RI. RI is a reserved instance. So standard RI can provide up to 75%, and maybe the number has changed. This provides around 75% of discount. You don't have to remember this number. So standard RI, the biggest drawback of this is you cannot modify. So there are this is 1 or 3 year reservation that you can do, and you can't change the contract basically. Let's look at, so this is not the option. Convertible RI provides a discount of 54% on demand, and they have the ability to change the attributes of the reserve instance as long as there are some rules around it. As long as the exchange results in a creation of a reserve instance that is equal or greater value. So basically you can do the conversion, but the conversion should result in a reserve instance that is equal or of a greater value. The attributes include, you can change things like instance family, instance type, platform, scope, and tenancy. So you can have single tenant or multi-tenant. You can change the scope. Schedule RI. Scheduled RI are instances that are launched within a time window that you have reserved. So this option allows you to match your capacity reservation to a predictable recurring schedule that only requires maybe an hour or a couple of hours of a day or a week or a month. So scheduled RI are good for recurring jobs which are only occurring within a time period. But this doesn't allow you to modify the reserve instance type. Second one, so this is not a valid option. B over here is elastic RI. There is nothing as such called elastic RI or elastic reserve instance in AWS. So for this particular question, C is the correct answer. This is the end of the show. Thank you for watching. Please click subscribe button and press the bell icon for notification on new episodes. This is your host Bhavesh Kumar signing off. Thank you. Take care. Bye bye.